Okay, in this second example, we're going to find the area between the curves y equals x squared and y equals negative 1/2 x plus 4. What makes this example different from the first is we're not given actual boundaries on the left and right for the region, so we're going to need to find the intersection points of these two curves in order to determine what our limits of integration are going to be. I know from a quick sketch that we've got the parabola y equals x squared, and we've got the line y equals negative 1/2 x plus 4. So I know that my line is going to form my upper boundary, and my parabola is going to form my lower boundary for the region in question. So I can go ahead and set up the integral a while. It's going to be the quantity negative 1/2 x plus 4 minus x squared. And now I just need the limits of integration. And in order to get those, I'm going to go ahead and graph these two curves on my graphing calculator. So I've got y equals x squared and y equals negative 1/2 x plus 4. And I'll go ahead and look at the graph of these two curves. And now the intersection points, the x coordinates will determine the limits of integration. Since I'm integrating with respect to x, I want the x coordinates of each of these points of intersection. So first I'm going to find the left intersection point. I'll go ahead and scroll up here and get outside of that intersection point so that I make sure it gives me that particular intersection point. And so the x coordinate is negative 2.265564. Negative 2.265564. And I like to, when I find intersection points on my calculator, just go ahead and use as much precision as the calculator gives me. Just in case, it gets us to our correct answer to 3 decimal places, rather than maybe taking fewer decimal places of our limit of integration. I would always rather use more than use less for those, just to guarantee more precision in my final answer. Then my other intersection point is 1.765, 5644. And so those are my limits of integration. Now I have the option to integrate this by hand. I don't know that I want to substitute those limits of integration in integrating by hand and do all of that calculation. So I'm going to go ahead and integrate this numerically. And so we've got the integral of negative 1/2 x plus 4 minus x squared with respect to x. Respect to x from negative 2.265564 to 1.765564, and hit enter, and we end up with 10.19. Let me try that again. 10.918 as the value for the area of this region. And that's the end of example 2 and the end of this lesson.